Thank you very much. So I'm Eric Cole. I work for Titan America. We are a cement and concrete company operating primarily on the East Coast of the United States. So I want to give the view of a cement and concrete manufacturer and how building codes and standards affect our ability to deliver low carbon building solutions. So as you probably have heard, the industry has released roadmaps for reaching net zero CO2 by 2050. So one on the right is the GCCA, which is the Global Cement and Concrete Association. The one on the right is the PCA, the Portland Cement Association for the U.S. And these just marked their 1-year anniversary from when they were released. And they look at the concrete, achieving net zero CO2 concrete. They look across the value chain and they look at the 5 C's. The 5 C's are clinker, cement, concrete, construction, and carbonation. And the key thing is that they're all linked together. So when we talk about codes and standards, it's not something that we can just address at the cement plant. Although cement does represent the majority of CO2, body CO2 in concrete, we have to rethink how we use concrete. We have to use it more effectively. We have to think about the construction process. And we have to take into account the fact that the concrete reabsorbs CO2 over its lifespan. And so putting all these together, we can see the role for the different portions. This is from the GCCA roadmap. And they show, so globally, if we continue to use concrete at the same way we make it today, the demand for concrete is going to grow. So the total CO2 is going to increase, as shown in that blue line, because society is going to grow, it's going to become more wealthy, it's going to demand more concrete ultimately. So we have to use concrete more efficiently, so we don't use as much concrete. And that concrete has to have efficiencies in design and construction, efficiencies in concrete and production, cement and binders, efficiencies in clinker production. As we go down the list, the big purple one is carbon capture and storage, which is another emerging technology that's the most significant one, as well as decarbonization of electricity and CO2 recarbonation. So all of these really require codes and standards. And when we talk about low CO2 concrete, it's important. It's more than just strength. Today, if you have an EPD for concrete and you set a benchmark, those benchmarks are typically based on 28-day compressive strength. In some cases, there may be criteria for early age strength for lightweight concrete, but really concrete is so much more than just strength. And so the resiliency, the durability, the life cycle of that concrete, the fact that the modulus, the elasticity, resistance to cracking, all those things determine the performance of that concrete and also the environmental impact of that concrete. And so when we talk about codes and standards and thinking about CO2, all of these things need to be reflected. And that's something that we're working through on these different processes. So let me give you a few examples, ways that I think we've had success with codes and standards and how we can improve and do better. The first example is blended cement. So 10 years ago, 2012, ASTM introduced Portland limestone cement, Type 1L cement, in ASTM C595. And you probably heard recently there are a number of press releases that have come out of plants that have converted fully to Portland limestone cement. This is a great thing because it reduces the CO2 in cement by 10%. And in concrete, that can mean probably 8 or 9% reduction in the CO2. But it's been a long process. It's been 10 years, and we only have 28 years left to get to 2050, and we've got a lot of changes left. It took a long time to change 50 state DOTs, all the other agencies, master spec, all the commercial specifications. So that took a long time. And blended cements are going to be an increasingly important way to reduce CO2, and we've got to do a faster job of getting those blended cements. So I have here a map. We went from Portland cement, so Type 1-2 cement, to Portland limestone cement. That's the second column. Now we got to go to the third column, which is 1T, and the fourth column, which is also 1T, but with slag, and other novel pozzolans. And so we're going to have to do that faster than we did with Type 1L, quite frankly. The next area is SCMs. If you look at the roadmaps, SCMs are a big role in reducing the CO2 of concrete. And there's going to need to be more SCMs, and that means we need standards, and we need these in the building codes. There are emerging technologies, things like harvested fly ash that's been in landfill, sometimes for decades, that performs as good, if not better, than freshly generated fly ash. Natural pozzolans are re-emerging. Calcined clays are also emerging, and even synthetic pozzolans, where they actually manufacture the pozzolan. It's not a byproduct; they manufacture it intentionally. So we need new testing for that. We already have reactivity and foam index in ASTM. There are more tests coming, and those are important. And then we need new standards. So we need to modify our existing standards like ASTM C615, which is the fly ash specification. That's being modified currently to have harvested fly ash. But also material specific specifications will come as these other emerging SCMs come. Another example that's very exciting is 3D printed concrete. And so, you may look at one of these structures and say, well, that's a lot more concrete than in a typical house. That seems like a lot of CO2 house or building. But when we kind of look at the overall where this is going, I would say that the building codes today do not allow for optimized use of these materials. Essentially, when we get a permit for one of these houses, it is typically based on a block wall construction. But the 3D printed concrete is much stronger because of the different shapes and things that we can print. We can optimize the structural design. We can optimize the thermal and energy efficiency of that wall, build a high-performance wall system that would be very time-consuming, very difficult to do with other kinds of materials. So we need to take advantage of that in thinking of the whole structural and thermal system to really get the most benefit out of concrete. So just to go beyond the savings from labor to all the other savings. Another example is carbon accounting. So all throughout the life cycle, accounting for the carbon that's spent or the carbon that is saved. And so one big area is embodied carbon. We do a good job with EPDs. That's been a success story. Recently, there's been emerging a lot of research that's established that concrete recarbonates over time. But that needs to be included in the standards, and it's a significant amount. It's 10%, according to the latest research. 10% of the cement CO2 is recaptured over time in the concrete, and there's even technologies that will accelerate the amount of CO2 that is recarbonated. And then carbon in the construction, use phase, and demolition, durability, resiliency, and avoided emissions. And so what's the role of building codes and standards? And I'd like to acknowledge the PCA. They put together a forum in Washington, D.C. a few months ago. I was there with ACI, ASTM, Army Corps of Engineers, a number of other key writers of codes and standards to look at what are some of the ways building codes can improve. And here's just a small list. There was a full day session. We had multiple pages of ideas. I tried to boil it down to a few key highlights. So we're going to need new codes and standards for new and modified materials. We need carbon accounting through the life cycle. And this is working on that. Others are working on that. We need to account for resiliency and durability. We need ways to quantify that and include that in our accounting. Another area is digitalization of acceptance testing. We over-design concrete because we have manual tests in the field that often lead to poor quality testing, and that means we have to over-design concrete more, and that's more carbon. So how do we meet the challenge in the timeline? So accelerating the standards development process while also maintaining the same rigor. So ASTM is doing a lot of things. Others are doing things to speed up the process so we can get standards through the process faster, help startups that have a good idea to get good data and be able to get a standard. Ensure that specifications use the latest codes and standards by default. That's something that happened with Type 1L cement. We got an ASTM, but then we had to go and get all those codes along the way. When ACA 318 is updated, it doesn't immediately go into the IBC. It doesn't immediately go into the local codes and standards. It doesn't get updated at the DOT. So that needs to happen, so we just use the latest codes and standards by default. We need to synchronize codes and standards across entities, and we need to balance prescriptive and performance requirements. Certainly we need more performance, but there's still a role for prescriptive. We need to think about standards about do no harm. So there's a standard in ASTM for admixtures. It basically says you can create a new admixture. You just have to prove it does no harm. You don't have to prove it does better. You just have to prove it does no harm. And so that's a good way for novel, innovative admixtures that don't have a place in the standards and codes to get in and get used, and then they can prove themselves over time. So those are some of the highlights. Lots more that we can do, and I'm sure we'll have a good discussion with the panel, but for now I'm going to leave it there.